In section 5.2, we want to solve a system of linear equations using matrices, and specifically the Gauss-Jordan elimination. And so we have a system like 2x minus 8y equals 12 and 3x plus 5y equals 1. And the first thing we want to do is we want to write it in matrix form. And so how do we do that? There's a common pattern in each of the equations in each of the systems that we solve. The first term is for x, and the second term is for y, and then there's a constant on the other side. And so we don't have to write the x to know that 2 is the coefficient on x. And we don't have to write the y to know that negative 8 is the coefficient on y. And then 12 on the other side we know is the constant that's equal to. And so in this way we can convert each equation into a row in the matrix. So the first equation becomes 2, negative 8, 12. And the next equation becomes 3, 5, and 1. And so this is called an augmented matrix. The left side is called a system matrix, and when we add on the 12 and the 1 on the other side, that's the augmented form. And so that's the form that we're interested here in this course. And so our goal will be to get the matrix to a new form. And that new form looks like this. And so this is called diagonal form. It's also called reduced row echelon form. That's a mouthful. That's a long name, isn't it? When we say diagonal form, we're talking about the diagonal from top left to bottom right on the left side of the vertical line. From top left to bottom right, that's the diagonal, and we're going to get ones everywhere on that diagonal, and we're going to get zeros everywhere else. You can imagine that if we had more variables and more equations, the diagonal would be longer. There would be more ones and more zeros in the matrix. We'll see an example like that later. On the right side, the A and the B represent some constants, some numbers that we don't know because, of course, we haven't gotten to the form yet. We're trying to get there. But what does this matrix say? So let's convert this matrix back to equations to understand why diagonal form is so good. In the first row, we have 1 as the coefficient on x, 1 times x, plus 0 is the coefficient on y, plus 0 times y is equal to a. And of course we can simplify that. 0 times y cancels, and 1 times x is just x. So we just have x equals a. That's the solution, right? That's the value of x that makes the system true. Okay, and then the second row of the matrix can be converted to an equation as well. It would say 0 times x plus 1 times y is equal to b, and we can simplify that and get y equals b. So that is exactly the solution to the system. So our goal here is to get from the matrix that we start with to the diagonal form. And the big question is, how can we do that? And so let's show you through the example what we want to do, and then we'll go back and we'll summarize at the end. So we're going to take, and I guess I'm going to move all the way over here to get some blank space. We're going to take our matrix, which is 2, -8, 12, and 3, 5, and 1. And we're going to remember that that's equivalent to 2x minus 8y equals 12, and 3x plus 5y equals 1. And so what I want to do is I want to show you some matrix row operations and that we can use to convert to diagonal form. And so the first thing I want to do you remember what number we need up here where the 2 is? We need to make that a 1. And so the way that we want to do that is we want to take the first row and just multiply by a half. If we multiply the first row by a half, we're going to go term by term. Half times 2 is 1. Half times -8 is -4. And half times 12 is 6. And so then that's the new first row of the matrix. The second row is not going to change yet. What's really good about what we have is now we have a 1 up here in the first entry for this first column. And so what did we do? It's a little abstract working with the matrix, but if we can relate this back to the equations, then maybe it will make more sense. So what did we do here? When we multiply the first row by a half, well, the row just corresponds to an equation. All we're doing is we're multiplying the first equation by 1/2. Multiply on the left side and the right side by a half, and we get x minus 4y equals 6. And of course, those are exactly the coefficients that we see in the matrix. We can just go ahead and bring down the second equation equivalent to the second row of the matrix. So what we want to do next is we want to put a 0 where this 3 is. Let me show you how we're going to do that. What we're going to do is we're going to take the first row and multiply by -3, and then we're going to add the 2 rows together. So -3 times row 1 plus row 2. And so the first row will stay the same. I'll just bring it down. And then what I'm claiming is that through this row operation, I'll get a 0 here in the first column in the second row. Okay, so in order to see why this works, let's go back to the equations. What is this that I'm doing? When I say I'm going to multiply the first row by -3, that means multiplying the first equation by -3, and then just adding that to the second row means adding the 2 equations together. So if I take -3 and multiply it by the first equation, I get -3x plus 12y equals -18. And then adding those 2 equations together, adding that new equation to the second equation together, that's the elimination method, right? I'm eliminating the variable x, and I'm left with 17y. And that's actually a -17 because that was a -18 there. I just missed my negative sign, but I think we're okay. So what I'm left with is 17y equals -17. X canceled, so what's the coefficient on x here? It's 0, so that's this 0 right here. And then the coefficient on y is 17, and the constant on the other side is -17. And so let's go through that one more time. Now we did it with the equations. Now let's look at it with the matrix. All right, so what I said is I want to do -3 times row 1 plus row 2. And when I do that, I'm going column by column. So -3 times the first entry in row 1 is -3 times 1 plus the entry in row 2. That's 3. So -3 times 1 plus 3 is 0. And so that's what I have here. And then I'm going to do the same thing in the next column and the column after. I'm going to do -3 times the entry in row 1 plus the entry in row 2. So -3 times -4 plus 5 is going to be +12 plus 5 is +17, and there it is. And then I'm going to do -3 times 6 plus 1. -3 times 6 plus 1 is equal to -18 plus 1 is -17, and there it is. Okay, it's a lot, so be patient here, and let's keep going with this first example, and then when we get to do a few more examples and you get some homework problems, then it'll start to make more sense. But at any rate, look, the good news is the first column looks just like we want it to, and so now we're going to go on to the second column, and we're going to make the second column look like the diagonal form. Remember, we want a 1 on the diagonal and then a 0, in this case up above. We always make the 1 first and then the 0 afterward. So what we're going to do is we're going to convert the 17 to 1. Can you guess how we're going to do it? Well, when we wanted to change this 2 to a 1, we multiplied by the reciprocal. We multiplied by a half. And so if we want to change this 17 to a 1, then what we're going to do is we're going to multiply the entire row by 1 over 17. So we're going to do 1 over 17 times row 2. 1 over 17 times 0 is still 0. So that's an important idea. We just made that 0. We sure don't want to change it. We don't want it to change to something else. 1 over 17 times 17 is 1. And then 1 over 17 times -17 is -1. And then the last step is to convert the -4 into a 0. So the second row is going to stay the same. And how do we make that into a 0? It's a little bit tricky. Let's see here. We've already done it once before. Let's see if we can make sense out of this. What we want to do is we want to take the brand new 1, the row with the brand new 1 in it. We want to multiply that by the opposite of this number here, and then just add the 2 rows together. So we're going to multiply row 2 by +4 and then add it to row 1. So we're going to do 4 times row 2 plus row 1. And let's see what that looks like. Let's come out to the side and write it out. So go column by column. 4 times 0 plus 1 is 1. And of course, that's good. We worked hard to make the 1 here in the first column, first row. We sure don't want to change it now. So that's the clever part of this procedure we're learning, is once we make something into a 1 or a 0 that we want, then it never changes after that. Okay, so we did the first column. We're going to go to the next column. We're going to do 4 times the entry in row 2 plus the entry in row 1. So 4 times here, and let's just make the color consistent, we're using purple over here on the side today. So let's get 4 times this 1 plus this -4. You could put parentheses around that. It doesn't matter. It's a 0, exactly what we were looking for. So that's a good result. And so then we need to do it one more time. We need to do 4 times row 2 plus row 1. In this third column now, 4 times the entry in row 2 plus the entry in row 1 is going to be -4 plus 6, which is 2. And so there we have our diagonal form, and we can go ahead and write our answer. Our answer is, from the first row, 1 times x plus 0 times y is just x. X equals 2. And the second row just says y equals -1. And so we could actually go back and plug those into the original equations and see that they work. So I think I'll save that for you to do on your own. So 2, -1 was the solution. Here's the original problem, and here are the steps that we learned. We learned row operations. We didn't interchange any 2 rows yet, but we'll do that in another problem. What we did do was we multiplied all the elements of a row by a non-zero number. And we did that to make a 1 on the diagonal. The other thing that we did is we replaced a row by the sum of the elements of that row and the multiple of the elements of another row. And we did that to make 0 off of the diagonal. And so that's consistent. That's the method we'll use to make 1s and 0s in general. And then what we did, we used these row operations to follow the Gauss-Jordan method to get a 1 as the first entry in the first column, and then to get 0s everywhere else in the first column, and then a 1 as the second entry in the second column, and then 0s everywhere else. And so in other words, the procedure is get a 1 on the diagonal and 0s everywhere else in the first column, and then go on to the next column and get a 1 on the diagonal and then 0s everywhere else. So we go from left to right, column by column, getting a 1 on the diagonal and then 0s everywhere else. So we have the basic idea now. In the next video, we'll have a couple more examples to help us practice.